So we're talking about sequences and series. We're going to be having a quiz on this coming up very shortly. We're just going to talk about several different aspects of this. The first thing we're going to find is finding a random term. This one is asking us to find the 32nd term, and the information it gives me, being that d is negative 200, leads me to believe that this is talking about an arithmetic sequence. So what we're going to do is use the arithmetic formula, which is a sub n is equal to a sub 1 plus n minus 1 times the common difference. And we're going to take all the information that's given to me and just plug it into the formula and calculate. In this case, we're looking for a sub 32, so I'm going to say a sub 32 is equal to a sub 1 is referring to the first term, which is negative 26. It's given to me in the information. Plus, since I'm looking for the 32nd term, n is 32 minus 1 times the common difference, which was again given to me at the beginning of the problem, is negative 200. Now this is a pure calculation thing. We don't really have to do anything special with this type. All we have to do is say what negative 26 plus 32 minus 1 is 31 times a negative 200 is, and that is negative 6,226. And if we extended the sequence out 32 places, that's what the number would be. That's the 32nd term of the sequence. Not all the time is it going to give me something like that. It's going to give me some other information, like in number 9. It doesn't give me a 1. In this case, it gives me a 2. So there are two ways that you can go about dealing with this. You can work backwards to find a 1, and once you have a1, do the formula like normal, or you can just treat a2 like it is a1, and then realize that instead of finding a20, you're going to have to find a19. I'd like to do the work backwards thing because I don't like changing the numbers, so I'm going to say, well, if a2 is equal to 16 and the common difference is negative 3, that will imply that a1 is, going to be 3 more than that, so it would be 19. You basically just add in that 3 to there. So a1 is going to be 19. And from here, we can work our formula out exactly the same way. I'm not going to go through all the steps, but it will now be a sub 20 is equal to a1, which is now 19, plus 20 minus 1 times the common difference of negative 3. People get these numbers backwards when they're working backwards all the time. Remember, it's originally going from 19 to 16, A1 to A2, and it should be going down by 3 at that point. So if we're going to go backwards, we have to go up by 3, and that's how we get to 19 there. It's all well and good for something like 2, but what if the first term is not A2, but the first term that it actually gives me is A sub 33? That's the 33rd term in the sequence. So I have a bunch of terms out here, and then I get all the way up to A33 is equal to 326. But I'm trying to find A sub 29. Alright, well, there's a couple ways I can deal with this. 29 is not that far away from 33. I mean, really, we've got 29, 30, 31, 32, and then 33. We could just work our way backwards and get to a sub 29. That would work fine, but if they're separated, we really do need to find a way to get to a1. So we have a formula. A sub 33 would be the 33rd term, is equal to a sub 1 plus n, which in this case would be 33, minus 1 times the common difference of 10. But the thing is, we really know a sub 33. A sub 33 is 326. Now, using this formula, we can write an equation. 326 is equal to a1 plus 33 minus 1 is 32. 32 times 10 is 320. And we can solve this equation relatively easy for a sub 1, which would get me 6 is equal to a1. So that just is a way that I can get back to a1. Once I have a1 and d, then finding a29 is just a matter of plugging it back into the formula with a sub 29 being what you're looking for. So that's how you deal with it if you're not given something like that. Now, when we're given a part of a sequence instead of a bunch of information, we have to determine, is this an arithmetic sequence or is it something else? So if we look at it, to go from negative 2 to negative 6, I go down by 4, but if I go down by 4 again, I'd be at negative 10, not negative 18. So this one is definitely not arithmetic, so we should check and see, is this geometric? Well, if it's geometric, we have to multiply by the same number. Negative 2 times 3 is negative 6, times 3 is negative 18, times 3 is negative 54. So this is a geometric sequence, not an arithmetic sequence. So if we're going to do a geometric sequence, we need to use the geometric sequence formula. A sub n is equal to a1 times the common ratio to the n minus 1 power. So what we need to do is figure out what a1 and r and n are. In this case, we're looking for a9 is equal to a1 is the first term, negative 2, times the common ratio, which in this case is 3, being that it's being multiplied by 3 every time, to the n minus 1 or 9 minus 1 power. So a9 is equal to negative 2 times 3 to the 8th. Please be careful, do not multiply the negative 2 times 3 first. You have to raise 3 to the 8th power and then take that answer and multiply it by the negative 2. So your a sub 9 would be equal to negative 13,122. And that would be the final answer. Very similar things happen with geometric sequences based on the information given. It can give you a1 and r, and this will be a very easy calculation using the formula. It could give you a2 and r, and again we'd have to work our way backwards. So if we have a2, we need a1. Well, okay, a2 is equal to negative 4. a1 is, or r is a negative 2, so we have to say what would I have to multiply by a negative 2 to get to a negative 4, and well, if we multiply a positive 2 by negative 2, we'd get to negative 4. So a1 is a positive 2. We're essentially dividing. When we go this way, we're just going to divide by r, and that'll get me what the previous term would be instead of multiplying by r. And that's, again, all well and good, but what if it gives me something more like this, where it's a6? Not a1 or a2 or something like that. Well, we can do like we did with the arithmetic sequence. We can say a sub 6 is equal to a sub 1, which I don't know, times the common ratio 2 to the n, which is 11 minus 1 power. Now we do know a sub 6, that is negative 32, is equal to a1 times 2 to the 10th. So negative 32 is equal to a1 times 2 to the 10th power. We need to solve this for a1, so that means we're going to have to figure out what 2 to the 10th is. And so this is negative 32 is equal to a1 times 1024. In order to get back to a1 from this, we will need to take and get rid of the 1024 by simply dividing. This is going to be a really small fraction, but it is what it is. a1 is equal to negative 32 divided by 1024 is a very small decimal, and so then we will need to convert that back into a fraction. We can also divide 32 and 1024. We can simplify that fraction, and that'll be 1/32. So negative 1/32. This is your a1. Now we'll be able to use that a1 is negative 1/32. We'll be able to use that in the formula to find a11. Again, we can use other processes. We say we know a6 is negative 32. We are going to then find a11, so 7, 8, 9, 10, 11. It really would not be that difficult to do times 2, times 2, times 2, and so on and so forth to get from 6 to 11. But if they were farther apart, then it would be a little bit more difficult. Now this is a recursive formula. Recursion is something that will be difficult for a lot of people. It's hard to tell if it's arithmetic or geometric just by looking at it. If we are looking for a specific term, like the fourth or fifth term or whatnot, in this case we are looking to find the first 4 terms of the sequence. We will need to find the first term, the second term, the third term. There is no formula to get directly from one to the other, because this is recursive. So we're going to have to start with a1, we're going to find a2, find a3, and then find a4. And now in order to do the recursion all the way through, we will say, well, a1 is 23, that's the information that's given to me, and we'll say a2 is equal to. Now whenever we are doing this calculation, a sub n minus 1, that is a sub 2 minus 1 plus 30. Now a sub 2 minus 1 is really a sub 1, because 2 minus 1 is obviously 1 plus 30. So a sub 2 is equal to a1, whatever that is, plus 30. Well, a1 was 23 plus 30 would be 53. Now we have A2, so now we can go ahead and try to find A3. A3 is equal to A sub 3 minus 1 plus 30, which is equal to A sub 2 plus 30, which is equal to the 53 plus the 30 that we had there. And that will give me 83 for the next term. And we can do the same thing. A sub 4 is equal to A sub 4 minus 1 plus 30, which is equal to A sub 3 plus 30, which is 83 plus 30. Now 83 plus 30 is 113. And these are the first 4 terms of the sequence. If I ask you for the 10th or the 12th term, you have to continue this process over and over and over again. You could realize that there is a pattern emerging from here. That is obviously a plus 30 relationship every time. And so this is an arithmetic sequence, and therefore we could use an arithmetic sequence formula to find that term.